getting the ROS bridge release out the door, and some blockers to that. But
yeah,
wait and see if Jacob shows up too, because he's kind of got the most context on
that. Okay. So audio note, this is the August 12th, 2021 meeting of the ROS WebTools working group. Hello, everybody. I have, let's see, should start my screen share. There we go. Started the meeting recording. Feel free to add yourself to the attendance list. Let's see if we had any action items from last time, which was call for presenters on discourse. Still haven't done that, although we've had so many topics of conversation the last few times that we haven't really needed any specific presentations. But I will keep that as an ongoing item to look at. This was, let's see, membership requests. This is done. I got a few of them. Let's see if we have any still open. This person probably should be in here. Let me double check. This is hasn't accepted the invite. Okay. Invitations. Does anybody on the call know MSoft 1 from Siemens? Nope. Okay. Anyways, that takes care of that action item. Started an email thread about message definitions work. I haven't had any chance to start working on that. Oh, I should probably blow this up like a step or two. I haven't started any work on that, but still looking for anyone who's interested to collaborate on it. You said maybe someone from your team at Foxglove was possibly interested in that.
Yeah, John would be a good
okay, John. Yeah,
contact. He's not here either.
Yeah, he didn't respond to the email, but if you want to ask him to reach out to me or give me his email, I can ping him directly. I haven't gotten any other interest, so it may just be the two of us working on it at some point.
Do you need to get like kind of buy-in from, I don't know, sort of what the workflow is, but like, do they need to kind of agree to
we're gonna need
a design or something before you start writing code?
Well, so what I was thinking is it might make sense to write a couple of quick and dirty prototypes to try out the various approaches we could take, and we could pair that with a design review, but not bother doing any of the cleanup work or writing tests or anything until we've decided on an approach. Because usually that first step of just kind of getting it working is 20% of the work.
Makes sense.
So hopefully not spend too much throwaway development time on it, but it's always worth it to just you always find a couple hours into the work what the major problems are with the approach, and discussing it around a table almost never gets you there. Okay, I think that's it for we want to release ROS Bridge Suite and the Foxy Galactic rolling, which is not something that we've done since the last time, I believe. There's been some talk on it, but I haven't done it. So
yeah, I was hoping Jacob was going to join today, but my understanding that the current outstanding blocker is there's a thing called, is it ROS auth or something, Roman? ROS auth. There's this like weird package called ROS auth that seems kind of unmaintained. It's not under Robot WebTools, but it's a dependency of ROS Bridge. If you find the PR where we're talking about the Foxy release, I think Jacob, or is it an issue? Maybe go to issues. was the one that called Foxy? Yeah, maybe go to the bottom of that. I think Jacob put an update here. Oh. Okay. I commented somewhere. Let me find.
Yeah.
So basically, we're blocked on an availability of this ROS auth dependency in ROS Bridge Suite. Our latest action is going to be just to remove that authentication feature from ROS Bridge Suite and to unblock ourselves to get a version of ROS Bridge Suite published and usable. If there is later demand to have authentication features layered back in because this module, had a feature or something that someone really wanted, they will voice their request and we can work on it at that time. But we view it as perfectly valid to just cut things that are blockers and seem unmaintained and unusable to get a working version of something for folks to use.
Yeah, I mean, ROS Bridge does not currently work with ROS2, so something would be better than nothing.
Yeah, I agree with that.
Also, I haven't really looked into the how ROS Bridge uses this auth library, but it seems to me kind of weird that we would need to do authentication within the protocol itself instead of just using offering configuration for HTTP auth and TLS auth if people want to use that. We could add support for that, but I don't know why we're even depending on this kind of unmaintained library.
Yeah. It also, I'm not sure, does this have a Foxy release? Is that blocking us for Foxy, or because the ticket there was a galactic release tag. So I don't even know if
I think it did have a Foxy release, maybe, because ROS Bridge Suite was released.
The exact same guy, yeah, go to issue 31. The exact same guy commented.
Oh, okay.
Has a closed issue. Jay Woodley, yeah, go to closed. And the first one there is the same guy. So
Joshua. Okay.
It sounds like it did happen, maybe, but
yeah. Okay, so this needs a little love. Is there any? Well, I guess the hard requirement would be to remove the hard. Yeah, remove the hard requirement on this ROS auth thing. Maybe leave it behind a feature flag where you could try to work on it. But that would get us forward into the next releases.
Yep.
Okay.
Yeah, I mean, releases are not, I think the way we view them internally, and this is how we work on our libraries too, is these are not like appliances, right? We're not going to ship it and never, be able to update this thing in 20 years, right? We're just going to ship something, and hopefully as people use it, they'll discover things and it will evolve from there.
Yeah, I mean, especially, or at least the way I think about it is that ROS distros need to at least have API stability so that your existing code doesn't break if we release something new within a given distro. I guess for the ROS Bridge Suite, this is robot side code, which means it needs to adhere to that. I guess for the web side, you could have a totally separate release track because the protocol, ROS Bridge protocol, is not being updated with it between releases here. So the client side could have a totally different release cycle. But this,
I agree. I think that introducing kind of unnecessary breakage is, if can be avoided. But I also view this package as one that is kind of the ROS Bridge Suite package is one that's getting a rebirth, and so there's an element of even if if we make iterations that happen to fall even within one ROS release distro because we added features or wanted to tweak things, I think that's okay. It's not, it's not such a core package, and it's not such a complete package where people can't be flexible, I think, to that. They don't have to always update their versions.
Yeah.
Yeah.
Although, sometimes people do a apt-get update or upgrade or whatever. Yeah.
Yeah.
So that's something we can also we can contain that information if that's the decision we want to make about its current state of stability, which is, as long as that's well documented that this may not actually be stable within a distro. You can note that given even a Rep 2004 quality declaration, which is used for ROS and I think it works for ROS 1, but it's mostly targeted at ROS 2. And it's got these quality levels, which cover like whether you promise to have API stability and stuff like that. So we could.
So far, we're also not breaking backwards compatibility within a version. Like the Galactic
nothing's been
version is going to be
released.
missing. Yeah, nothing's been released for Galactic. Like we're removing functionality that technically existed in Foxy, although I'm not convinced anyone used it. Yeah, like within the Galactic release, we're not breaking backwards compatibility.
Yeah. Galactic's also, I mean, those like short-term support releases are less of a concern for me than the long-term support ones. Like Foxy's going to be live longer than Galactic, and yeah,
I didn't know that.
Yeah. So Galactic, and every other release is a 1.5-year support short-term release. Foxy was a 3-year support release. So they actually, Foxy and Galactic may go end of life right around the same time. But then Humble will be the first 5-year support release, and long-term supports will be like that from then on. So that means that, for example, Humble will outlive Turtle by a good deal, a few years.
So you're going to get everything into Humble, basically.
Yeah, Humble, I mean, the way I'm thinking about it is Humble is like ROS 2 1.0 for realsies this time, whereas like Foxy was a real solid beta.
Yeah,
I mean, that's just my personal
take. To know. Yeah, that's very useful, actually, for sure to know. Another thing that I would probably highlight is that because the ability to introduce packages into the build farm and to like kind of add things to the ecosystem is fluid, and I think that's a wonderful thing. I think there is, at least in my mind, a notion of like what is more okay to break. Like, I certainly wouldn't expect the entire pub sub mechanism to change between ROS releases, but more like kind of as you move more and more towards like user space things, I think that, at least the way I look at it is that between releases or even, within release, like there can be iteration. I always looked at ROS releases as more of like, what are the core packages doing and how are they churning? And less about, things that exist in other orgs or in other repos or anything like that.
It's true. I mean, it does depend, in my thinking, on whether you're talking about an end application, which can change all at once, or a utility that you're vending to somebody. And in this case, like the ROS Bridge suite is a utility that we're vending to people. And so we want to maintain some semblance of stability. But at this early stage, like, very first ROS 2 releases, I agree with you. We don't need to be strict about that. And until we make any explicit promises about it, it's, you're not breaking any contracts until you make the promise in the first place.
Is there any notion of, and I guess maybe this quality thing is that indicator, but is there any notion of like things that do want to kind of consider themselves as part of more core functionality, they live in a particular organization? Or is it always kind of this distributed, like robot web tools can have things that, maybe are considered more core, and it's just
there's a few definitions of what is a core. So there are these ROS 2 variants, and these are the things that most users will install when they install ROS, and as their first install, So there's the core, there's the base, and there's desktop installation.
Yep, familiar with these. Yep.
Yeah, these build on each other. So core is a subset of the other two above it. And so those ones, largely, not entirely, but largely live within either the ROS 2, ROS visualization organizations. There's a few outside of it. But when you get into ROS core, I think it's almost entirely ROS 2 organization repositories. But there's also the Rep 2005 ROS common packages. which is a different kind of a list that its meaning is a little bit vague, but it's considered like what is the, I don't know, it's what the TSC cares about is basically what this list is like people who are part of the TSC contribute to these packages. And it's a pretty long list. There's not a huge barrier to entry other than a couple of TSC members agree that it should be in there. And so this is like maybe another slightly consideration of core. It feels like a recommendation from the leaders of ROS as to what packages are good to use.
Okay.
But yeah, it doesn't have, this one's like not as meaningfully weighty as the variants. Like in ROS core, I'm pretty sure the attempt right now is to get every package in there up to quality level 1, whereas the ROS common packages doesn't have any specific quality level promises. So yeah, so if we wanted to like label ourselves quality level 4 and meet these requirements, that would be a useful signal to the community. To get to 3, you need to, to 3, you still don't actually have to have a requirement about stability within a API stability. So you could get up to 3 without promising to have a stable API.
Okay.
Yeah. But if you want to get up to quality level 2 or 1, you need to have these within distro stability promises. So I think that's a useful signifier for us to just tell people what we think about a given release.
Yeah, absolutely.
Yeah.
Dira, since Dira joined, do we want to roll back and start with his discussion topic?
Yeah, I think that was a good little.
Yeah, that's all we have
tangent.
for ROS Bridge Suite, by the way. That's the end of that topic.
Okay. Great.
Sure. Hi, everyone. So there's a few things I wanted to share. I think, and then like possibly a couple of things to discuss. And let me see let me try to get back to where this agenda was. Yeah. Okay. So first of all, like, I wanted to show everyone like I made several improvements in ROS board, which I can show you sort of briefly here. And some of those things include, for example, Valodyne point cloud, so you can pan and view these around right now. So it does support that, and there's a whole bunch of different topic types it did not support before. You can also view the system message output here. So if you have a robot and you're wondering, why did my camera go out? You can go and look and see if there's an issue with USB or whatever. You can also look at the process list and see what's consuming CPU. It looks like Chrome's like consuming all my CPU right now on this machine. Turned out like I was actually thinking that this was consuming the CPU, and then like I actually closed ROS board and it was still at 700%, and it turns out that Google Hangouts is like eating all the CPU. So I find that was actually impacting the performance of ROS board because it's literally taking all the Hangouts is literally taking all the cores. Yeah, I don't know that. So one of the things I wanted to sort of, and by the way, one of the things I wanted to stress in ROS board is, being mobile friendly in general. So, here's if you can see, let me unblur my video here. Yeah, so here's a Valodyne point cloud right on the phone, and you should be able to pan and rotate that, do everything right there on the phone. So one of the things I really like to do is to be able to take my phone and walk around with the robot with the phone and be able to like do things to the robot and see what happens to the sensor outputs on the phone. It was always like a very convenient tool for me, especially because like it's not that convenient to like have like a multimeter or oscilloscope in one hand and a laptop in the other, but a phone, I can go and be viewing currents and then put resistance on the wheel, see what happens. And so that's one of the things I was really going for. There are a few other interesting things I did add to this as well, including let me find one of these. So that bag did not have a laser scan in it, but this one should. Yeah, so here's the LiDAR scan. So one of the things, I've always wondered sometimes is like, I want to know, where some actual coordinate is in the map. So it's not only labeled, but it'll actually sort of track those objects for you for a short amount of time. And so, these are just all, simple hacks that I've had to use before in the course of robotics. This is obviously not any advanced tracking, but I find this helps a lot when, for example, you're trying to create a robot, let's say, that has 4 posts and the LiDAR inside, and you're trying to figure out where exactly the posts are. So you can sort of just click things and track them like that. So, that's also kind of handy. One of the things that I do with a lot of these with a lot of these topics, and this is where I wanted to try to see, at some point, whether there's any way to include them in, any sort of bridge. Even though this is not really, it might be hard to standardize this, but let me show you what an internal. So right here, I've paused the video. I'm just introspecting into exactly how the message was sent across to the from the WebSocket to the client here. And what it does is it actually compresses the ranges. So instead of, it doesn't actually send the ranges over as is, but instead it sends a Uint16 compressed version where, okay, this is base 64, and maybe I'll go to CBOR at some point. But basically what it's saying is between this value and this value, it's a series of Uint16s. And so that basically now I've compressed every 32-bit float into 16 bits. This is just the min range that appears in the array. This is the max range that appears. And I do the exact same thing for Valodyne points as well. So for example, let's see. Oh yeah, I need to instantiate it first. There we go. So pause that, and basically you can see here what it's doing is it's sending the entire point cloud array, but each of the it has a min max for X, Y, and Z, and then it compresses all that into Uint16. So I know I sort of invented my own little compression thing here, but it's it's taking the original point cloud message, which was I think it was 20 bytes or something per point, and now it's going into 6 bytes. So pretty efficient right there. So and then I think further down the road, basically in terms of like the amount of resolution loss you get, I mean, for 100 meters, that's 3 millimeters of resolution, I think, at 16 bits. So that's more than enough because you don't even get that resolution. I mean, Valodynes are only accurate to like a centimeter or so, I think. So I also want to try to do the voxel deduplication stuff where you only pick one representative point at each voxel. So that's also something to be added. Yeah, so that's also in the works.
So yeah. I mean, just because that's interesting, I feel like you could have a compressed point cloud message type that then is interpretable on both sides, and you don't have to come up with something special for the bridge itself, right?
Yeah, right. So that's an interesting question. But then how, like basically the question would be, suppose I want a custom compression. It does, by the way, it doesn't have to be custom. It just has to be good.
Yeah.
And let's say all I want is compression of point clouds. How do I achieve that with a standardized ROS bridge as opposed to a custom ROS bridge, which is what I'm doing? So like my custom ROS bridge realizes that this is a point cloud, and it does a very specific lossy compression on that point cloud, which here is very naive, and there's more I could do. But what basically can we incorporate standard compression techniques into that? Can we create a sort of compression transport that ROS bridge will take in? Or
yeah, so I mean, my thought on it was, I don't think that the transport layer, the bridge itself, should have to know anything about this.
Yeah.
you could just have a node on that side that transforms point clouds into this compressed version, which has a strong ROS message definition for the compressed point cloud, and that then gets passed across the wire.
I posted an example in the chat of a popular point cloud compression algorithm applied to ROS point clouds.
Great.
But yeah, using something like that, I think it's purely on the client and the node sending it to understand that format.
Yeah, and then the transport just passes messages blindly. It doesn't have to know about, you do the compression beforehand, because the rest of the overhead on the message wasn't the concern, right? It was the points themselves.
Yeah, but then would you publish it to a new topic, or how would you?
You would say like /points/compressed or whatever, like you do with images right now. Is at least that's the way I would think about it as my first instinct.
Yeah, but then on the other hand, like for example, even for compressed images, right? Like this compressed image is in the bag, but in fact, my bridge actually recompresses it to compress it even further. So it's like just, and although I don't have that yet, I do want to at some point have dynamic levels of compression so that when it detects low bandwidth, it should be able to compress it more. So
I mean like WebRTC, right?
Yeah, I think like in the long term, I'll end up doing WebRTC for all of this, but I'm just not there yet in terms of like how do I get a whole lot of other topics other than images to go over WebRTC in a nice lossy fashion that keeps up with latency. But that's I think I'll probably end up there at some point in the future.
Yeah, I mean it's an interesting consideration because there's so much work around specifically transporting images that you can sort of special case take advantage of that for that type of data. That and audio, although we do less of that on our ROS robots, I think. But
yeah.
Yeah.
Sorry, I think you were saying something.
I was just gonna say that I think this is where it gets into a little more of a divergence between like what you're trying to accomplish at an app level and like some assumptions you're making about app versus, kind of if you just take something like the bridge as just moving, connecting the ROS system to client, not trying to make as many assumptions around app or anything like that. I'll also say that the bridge already does have sending binary data, right? And we have, in our experience, pushed lots and lots of data over the bridge, and that works, right? Like that works on localhost. It works quite well, like without introducing additional compression or anything like that.
Yeah.
So it does kind of decide. It gets into a little bit of like, yeah, you can make a lot of these assumptions, if you have a specific use case in mind and a robot use case in mind. But there's also the opposite end where people do want to see the full fidelity. They do want to kind of be able to get the data as it's coming off their robot or out of bag files. And so I think there is an interesting question there around what is happening at the transport layer and what can happen automatically versus like, what you want to get that's just representative of what your robot was sending over.
Yeah, I mean, I think if you're building an application that could benefit from WebRTC, you can always pass your video data along that side channel and then use ROS Bridge for the rest. I mean, maybe making an easy way to do that would be valuable.
Mm-hmm.
Yeah, I mean, I think it would be kind of nice if that were entirely
within one thing.
Right, like basically you don't have to worry. Look, because like programming WebRTC is not for the faint of heart for roboticists who are not used to doing JavaScript. So like sure they can learn it, but if behind the hood, like under the hood, ROS Bridge just upgraded to WebRTC whenever it could, that would be kind of awesome, right? Now the question is like WebRTC, it's great for images, it's great for audio. How do you do point clouds? I don't know. If we can somehow squeeze point clouds into the WebRTC paradigm, I think it would be awesome to have that, so that I don't even have to know how it's working, but I get a point cloud on the other end.
Yeah, WebRTC is just it can be used as a transport layer.
They're data channels. Yeah.
Yeah, you can do all that. It's just it kind of again comes back to like the benefit versus the trade-off, right? Like if you're on localhost or wired to your robot, there's a very limited benefit. You know, if you are on a Wi-Fi network with the robot, maybe you could start to talk about how there may be a benefit. But again, you're already peer-to-peer with WebSocket Bridge, and so what WebRTC is kind of designed, it's allowed to peer you through, you know, to another peer on the internet where you have just a coordination server, but the data goes between the peers. But like the way WebSocket Bridge already works is you're already peered to that robot. So it's kind of, I'm not entirely sure what you buy by using WebRTC.
I think the main thing you buy is that WebRTC is capable of doing UDP, and it's capable of doing fire and forget messages. It's capable of detecting latency conditions, dropping quality automatically, and then advancing to the latest frame. Whereas WebSocket will found like routinely, if I say, you know, I've done experiments by, you know, deliberately injecting packet loss into my Wi-Fi and things, and what'll happen, and, you know, even just like taking my phone and walking out to the parking lot and watching my Wi-Fi go down, basically what'll happen is like there'll be a huge backlog of WebSocket messages that as soon as I, you know, come back, it'll like all just plow through all those huge backlog of messages and sometimes even crash the phone. So
it's got the built-in paradigms around live communication and potentially low bandwidth scenarios. I mean, my primary experience with Robot Fleet is over cellular data, and so it's super expensive. So we needed that compression and to drop the quality as much as we could while still getting a reasonably live stream. So I mean, I think the advantage there is that you do get these big data streams, data and audio, or video and audio, with a lot of the paradigms around how to use that effectively. Just built in. You don't have to think about it. I don't know. It's got, you know, VLP9 or whatever you've got built in there. Yeah. So again, it's like different uses for different applications. Like maybe you could have a plugin to the ROS Bridge suite that's a WebRTC video plugin, because there are native nodes that you could install, but it wouldn't have to be built into the transport. It would be an extension to the transport. I think it's interesting topics, but until we have someone to develop on it, it's maybe not. Maybe we don't need to get too far into the weeds. Yeah. I mean, I definitely think it would provide value. We got a lot of value out of it for our robots on cellular out in the field.
No, that's useful to know the context around it. Yeah, it's helpful, and we'll certainly, you know,
it seems like they are very useful in different situations. And you know, like the WebSocket full fidelity is really useful if, for example, you are, you know, debugging with a browser with Studio or something like that, and you're connected to just like ROS running on localhost, then, you know, who cares? You just want like all of the data. But yeah, if you're like chasing around a robot in a parking lot that's on cellular connection. Like,
or if you're sitting back in the office looking at a robot that's 7 blocks away on cellular connection.
Right. Yeah. I mean, like I fully intend ROSboard to be usable with live robots over, say, a VPN. So like, let's say you want a VPN into your factory that's running a bunch of ROS robots, and you just want a ROSboard into any of them. You could just do that over VPN, right? And then obviously you might have a whole lot of, you know, bandwidth issues in the entire link between you and the office.
Yeah, I guess you could just subscribe live. You don't even need a special connection for that if you want to do a native system. I mean, you could pull up RBiz then.
Yeah, you could, but then like, you know, I want to try to, like, especially with things like ROSboard, I want to try to support the ability to deal with low bandwidth very gracefully. So like, you know, let's say you only have 300 kilobits of bandwidth between you and the office. Unfortunately, like RViz web, you know, X forwarding is not going to work well on that. But, you know, WebRTC, you know, image streaming will work just fine on a degraded image. And, you know, hey, you can at least do a basic teleop and see what's going on. So I want to make sure that, basically, I want to try to make sure that ROS, because like one of my big focuses with ROSboard is live robots. I want to try to make sure that I can support it all the way down to like the crappiest bandwidth to the best we can do at that bandwidth.
And I think the useful thing to think about here is making sure that your transport layer and any extensions to it can handle these bandwidth scenarios and is configurable for it, and that any given board is a front end, not a bandwidth manager.
Right.
Whenever you're dealing with a fleet that you're not connected to directly, there's always the question of the proxy, right? Because obviously on LTE you can't get inbound connections. In WebRTC you'll need a churn server. Have you thought about this? How you would solve that in a general case? I mean, obviously if you're setting it up for your own fleet, like your Amazon and whatever, you'll bite the bullet and you'll set that up. But
yeah, I used to work on delivery robots before in a startup. So outdoor delivery robots, they were over LTE. We had both. I mean, we had a full blown like 4-camera thing going with WebRTC and Teleop, and it was just fine. Like obviously, like we avoided sending the robot down into places with poor reception, but the bandwidth would fluctuate anywhere from 100 kilobits to like 15 megabits. It would just fluctuate in between these extremes all the time, and we had to deal with that. And so WebRTC was very much the answer. It very much like it made it work pretty flawlessly, actually.
I think the question here was more around the proxy server, the stun and turn servers that you need for WebRTC.
Yeah, that was not the issue, because like I think basically like our server was on AWS, and we had a co-turn server on AWS as well. And then I think there was also the public turn servers, which I don't know if they exist anymore, but like we had co-turn running. Anyway, like between those, like there was no latency or bandwidth issues between any of that system. The only bandwidth issue was between the cell tower and the robot. That was the only bandwidth issue in the entire system.
But I think you can make it pretty easy to set up a turn server for someone who wants to do that, right?
Yeah, co-turn. Like it's pretty easy to set up.
Exactly. So you do have to run infrastructure, but probably not that big of a deal given that we have AWS and Google Cloud Platform these days. Yeah. Okay, sounds like we've reached maybe a lull on that topic. Is there something else we wanted to hit?
I guess are there next steps there on like, I mean, either do you want to propose something concrete for like an optional sort of downgrading WebSocket thing, or propose like a standardized WebRTC connection to it?
I think a good first step would be to create an issue on ROS Bridge Suite and request WebRTC for video as a first step, because there was then a slightly more vague conversation around could we do something like that for point clouds, and I think the first step is just you have client and server and client and robot side code that can understand and compress point cloud messages, and you just pass them across
I think. Plus, I mean, I would, so, I mean, before we get to the point cloud stage, if it's possible to have the ROS Bridge server and the client library, as in ROSLibJS and the ROS Bridge, transparently support WebSockets for image topics, and then we can switch those around at some point in the future. As long as the APIs stay the same, people will not know when algorithms are upgraded. Basically, it'll just work. But I think that could be a good first step. The only thing is, I don't know. See, the client side is easy because all WebKit browsers have WebRTC. You don't really need any additional libraries for it. But on the server side, it could get a little tricky. Because, okay, I know there is a Python library called AIO-RTC we can use. I think
there are C++ implementations too that we could wrap. There are at least 2 WebRTC ROS2 nodes that I know of. Yeah, I don't know the link off the top of my head, but I've seen demos of both of them. They may need development or new owners or something, but it's definitely one of those things that's possible as a pure C++ ROS2 node.
Okay. And are there any comments on potentially making the entire ROS Bridge C++, or is that beyond?
I think it's still worth exploring whether this can be done above the ROS Bridge transport layer. I could imagine a node that advertises a topic, and if your client understands that topic, says, "Oh, there's a URL in here or a link to a WebRTC transport. I'm going to attempt it," and do it completely side channel on top of whatever transport you're using underneath. I think that is worth exploring and seeing how far we could get with that.
It's a good point.
Yeah, I don't disagree.
I commented on the C++ question. There's like two elements. One comment I didn't make. The one comment I made was like a technical blocker. So we found a workaround in Python that let us hoist the message definitions out. So one of the important pieces of the WebSocket bridge for us, at least, is to be able to send the message definitions to the receiver, at least to be able to handle like if you send raw data. But outside of that, there's not many other technical limitations in, besides like someone doing that, deciding which WebSocket library C++ to use and figuring that it's worth it or not. That's where that basically stands, is it's more of a who wants to do that implementation and if it's worthwhile or not.
Yeah. Sorry, did you
Yeah,
touch on performance at all? I'm wondering like how much of a performance benefit you could get between a C++ versus Python implementation, because there are people running on resource-constrained robots who still may want to stream their data off.
Yeah, I think especially Raspberry Pis, which are exceedingly common.
I mean, I think Raspberry Pi is the good like hobbyist example, but I'm thinking more of more engineered robots that are using, say, like a Rockchip board or some other Qualcomm board.
Yeah, no, I mean, I get that. I mean, it's like there's plenty of computes that are equivalent to that as well. Like
Yes.
I'm sure, like Jetson Nanos, Jetson whatever, like basically all the Jetson stuff is pretty widely used in industry, and then
Yes.
that's also pretty compute limited.
It's a tough question to answer. I can say anecdotally, I built a C++ WebSocket server that was compatible with ROS Bridge for ROS1. We ran it on Jetson Nanos. CPU usage never really went above a small single-digit percents, but it's a huge anecdote.
Yeah, I mean, I'm assuming that code is not share. Is that code out there open source or is that closed stuff?
It is not right now. I can go inquire about making it open source. One quirk of that is that it was actually attached to a non-ROS stack. So it actually had a whole little miniature like ROS serialization library built into it to speak ROS. So I don't know if it's directly applicable, but it might be an interesting reference code.
Yeah, at least the whatever WebSocket server you chose to write in C++, that would be useful to know. But yeah, so it depends on which Python path you pick. Certainly running Python overall is going to be a little more heavier weight than just maybe a streamlined C++ node. But again, also if you pick the what we call CBOR raw serialization, then that is also a little lighter weight than if you just go for the JSON or even CBOR serializations in Python in the WebSocket bridge, because those have to actually take the raw binary ROS, deserialize it and transform it into something else and put it on the wire. Whereas if you use just the CBOR raw, you're really just kind of taking the already serialized ROS bytes and sending them again back over the wire. And so the amount of work being done is just less. So that's also another way to kind of keep the CPU usage of the Python version down. Just kind of throwing that out there. But
is there a reason that we don't make CBOR raw the default and just write a really good client library that does the deserialization for people? Like people don't really need to know what the wire looks like.
Yeah, the reason being that we haven't done it.
I thought that's the case. I know WebViz and Foxglove both use the raw transport by default.
Yeah, I guess I meant like for
so CBOR raw was
for the client and server libraries.
Yeah, so CBOR raw is like only a thing that was added. I don't know if in ROS1 it was ever even released. Maybe it was. Jacob would know, but we certainly just added it to the ROS. It was? Okay, good. And then the other thing, the other thing is that I think outside of ROS Bridge and outside of ROSBag.js and WebViz, I don't know how many other people were using our message deserialization stuff in the client side, right? Like most folks that were using the ROS Bridge stuff as it was would just receive the JSON messages. They didn't want to then take in the message defs, build the deserializer and deserialize client side, right? So those are the trade-offs you face around that. Whereas if you just use the JSON feature of the bridge, you don't have to worry about any of that. You're just getting JSON messages.
Well, ideally,
Yeah,
if you,
Yeah.
ideally, if you used raw transport, the client library would deserialize them for you and deal with that transparently.
Yeah, and we have all the libraries and tools like that. That's what we use in Studio. That's exactly what we do. It does get into questions around like which browsers are you targeting? What do you want to do for that, right? For example, our libraries and things that use pretty new things like BigInts and whatnot that not all browsers support. So you open up more questions with that.
Can I ask what CBOR raw is? I don't think I've ever heard of that. Or how do you spell that?
It's actually two things. CBOR. One is that CBOR is a binary serialization format. It's basically a binary JSON that's been ratified by the IETF. So it's a well-documented, understood standard, pretty good. But then the raw part refers to basically using the CBOR serialization format as a very thin container, and then just shoving raw binary ROS TCP messages into that container. And so for the transport, the ROS bridge's perspective, it's receiving a binary payload, putting a tiny little binary wrapper around it, and then putting it on the wire.
For context, I linked to the GitHub PR that implemented it for the WebSocket bridge, ROS bridge suite, sorry. And the reason it's got this weird name is because the ROS bridge suite already had a CBOR transport mechanism for moving binary data from the server to a client. And this is kind of added as an additional tweak onto that existing mechanism. And that's why it carries this weird CBOR-raw naming in the context of ROS bridge suite.
Yeah. Has anyone done a good benchmark of CBOR, given that it's not native versus like a native base64 and then just directly to a data view? Because like basically, so in ROSboard right now, I'm sending things as base64 because I'm finding that base64 gzipped by your standard Tornado browser gzip stuff. It ends up being basically almost as efficient as if you had just sent the binary stream, because it deals with the 2 zeros at the start of every byte very well, or gzip deals with that very well. And then on the client side, the zlib decompression is very efficient. That can handle gigabits a second. And then you have the base64 decode, which is native, and then that goes into a data view. And I found that super efficient in terms of like timing, like in terms of just efficiency on the client side with JavaScript. But I wonder if there's a benchmark for CBOR, or I could probably write that benchmark and just see what happens.
It sounds like the issue though is that that's not your bottleneck. If compressing data and then turning it into turning something into a larger string, compressing it, decompressing it, turning it back into binary is super fast, then that just means you're not bottlenecked.
Oh, so
that,
yes,
right?
that's typically true. But then when you get to mobile, like if you want to view a point cloud on a mobile device, then I found that I really needed cutthroat efficiency on the client in terms of dealing with binary data. And base64 followed by data view seemed to be very efficient on Chrome mobile, at least on Android.
Yeah, it sounds like it works fine. Any benchmarks are going to be really specific to the implementation. Like, for example, with CBOR, there's an opportunity for a lot of the data types to just create a view. So instead of actually parsing a 32-bit float or 64-bit float, you can just create a lazy data view on it, and then maybe your application doesn't even need to read that. We take advantage of that in different parts of our deserialization, but that's very application specific.
Yeah, I mean, what we do, like you're saying, encode it as base64 and then decode the base64 and put a data view over it. I mean, that's pretty much what we do, except that with the CBOR raw, we just send the ROS message over the wire and then do a like lazy deserialization of like just individual bytes within that ROS message. So it sounds pretty similar.
Yeah, I think you'll find that the CBOR part of the CBOR raw transport is like an 8-byte prefix or something like that. The actual CBOR encoded data is very minimal. It's like this tiny little header. The real payload is just a raw ROS message.
So yeah, I guess like this doesn't need to be an immediate thing, but I would float that it might make sense. I mean, in line with the kind of proposal of separating out the ROS Bridge client library from ROS.libJS and just having like a dedicated ROS Bridge client. Like once you get to that stage, we could put we could make CBOR raw the default that client requests, and people would just use like, the ROS message deserialization stuff that we've already written, and like the clients wouldn't really need to know, but it would just like be magically a lot more wire efficient for them. Rather than like, I assume right now the client defaults to JSON or something, which is like probably a terrible idea for anyone to be using.
I mean, depends what your use case is, right? But yeah, it does that because it's the easiest thing to just literally take, a script pointed at the WebSocket connection, start seeing, data that you can comprehend come over without any additional libraries, right? So it's a trade-off. It definitely exists from a different time where I think using, more and more modules was harder, whereas now it's easier to do. And so maybe we can do that.
While we're on the topic of protocols, I just wanted to give a quick status update on our ROS2 implementation effort. I have a library, an RTPS implementation now that is able to subscribe. Publishing is coming soon, it's almost there. So we should be able to see a prototype of native ROS2 connections in, I'm going to say maybe 2 weeks now.
Sorry, can you give a little more context on that? You're working on a DDS or RTPS implementation that talks over the web?
So it won't be directly over the web, sadly, because to speak RTPS, you do need UDP. And so it's going to be restricted to either Node.js or Electron or an environment where you can provide UDP sockets. But anywhere where that you can get a UDP socket, you can speak directly to a ROS2 system without a bridge or any other intermediary.
Okay, and this is, I guess, like a parallel product to RCL Node.js. So
That's right.
Instead of tying to the C, you're just doing an implementation yourself?
Yeah, this is a full TypeScript implementation, so there's no build step, and it's platform portable.
Interesting.
Yeah, it's
do you want to speak to like why it was important to us not to use the RCL?
So RCL is a little different philosophy where it assumes that you have a ROS2 installation. You have all the local message defs of what you need, and so you're kind of jumping onto a ROS2 developer's computer, and you're running code from there. And we wanted, for all of the plugins in Foxglove, the idea behind the product, or one of them, is that you can install it anywhere. You can just take a fresh Windows or Mac Linux computer, install this product, and you can start running. And so we don't assume that you have even a compiler, let alone a whole ROS2 install. And that's why we needed a fully standalone system. So it's complementary to RCL. I don't see it as competitive. If you want a system that plugs into your ROS to install with all of your extensions and your custom plugins and things that you've selected, RCL is the way to go. If you want something that connects to a more or less vanilla DDS system that's ROS2 compatible, then I would point to these libraries that I'm working on.
Okay, and this is good for a LAN or a VPN because you can get that UDP traffic. Got it.
That's right. Yeah.
Okay, so you're doing it on a the idea is you're doing it on a computer that is not the ROS computer, but the ROS computer is somewhere within your immediate network.
Yeah, it's accessible over the network.
Yeah, cool.
Yeah, this is a parallel track to our. So we have support for ROS2 connectivity in Studio today, and that uses the ROS Bridge Suite package, but that obviously transports over WebSocket. This is what will this is the analog to the ROS1 native connection we have in Studio, where you'll be able to connect directly to a ROS2 system. You won't have to connect over a WebSocket bridge if you don't want to. It's just more optionality for connections.
Cool. Do we want to, just because we only have a couple of minutes left? Yeah, go ahead.
Are there any other? Are we the only people crazy enough to be creating a native ROS implementation that's not based around RCL? Do you know of any other languages or attempts at that?
No, I know of people building DDS implementations, and that's their core product, and we import those into ROS and use them through the RCL layer. And most of those are built in C or C++. Or I think they all are. I know Cyclone's built in pure C, and then the other implementations, I don't know what RTI is built in. They're all closed source, but I assume it's C++. That's their main API.
One thing I would like to do, which I just haven't gotten the time for, but if I have time to explore, just throwing it out there, I really want microcontrollers to be able to be ROS2 nodes on the network. I know there's this XRCE DDS stuff. The only
micro ROS.
Yeah, the only thing is it wants an agent that's living somewhere else, and that seems like that completely breaks the whole decentralization model. And so I would prefer that the ESP32 or the whatever microcontroller you use is completely self-contained and can speak DDS and everything on its own.
Sorry, can I, I think I'd like to redirect that conversation, given that we only have a minute left here. That sounds like a really good topic for the embedded working group.
Okay.
I'm not saying like we can't talk about that stuff here.
I didn't know there was an embedded working group. Can you send me a link?
Yeah, I mean, everything's on the ROS2 governance page, or the what do you call it? The events calendar, which is embedded on this page. So, I mean, the embedded working group, I don't know how active it is. It's not something I've been to recently, but it's worth checking out if those folks are talking about anything. Those they're running the Micro ROS project.
Yep. Okay, cool. Thanks.
Yeah. So just want to make sure, Audro, do you want to talk about your points here out loud, or was this just meant to be like, hit me up if you have anything? Yeah.
Yeah, I wanted to put all the information there just in case I didn't get a chance to talk about it.
Yeah.
But I'm happy to talk about it. So first, basically 2 announcements from like the open robotics side. So I'm the ROS2 humble ROS boss. If you have any, and we're still figuring out the roadmap. If you have any features that you'd like to see that you think will be important, feel free to email them to me or use this link to schedule a time to talk. I think all I really need to understand the things you'd like to add would be like a motivation and like a description of what it would look like. And this would be on the repositories that the open robotics people maintain. So if there's anything we can add to make it easier to do different web tool applications, and I don't know exactly what that would look like, but if you have anything in mind, we want to be supportive of growing in this direction.
Yeah.
So that's the first. Yeah, go ahead.
So I think the one thing that this working group keeps hitting on that we'll probably want to talk about is message definitions on the wire, which we've just started that conversation on the ROS2 repo for that. So maybe we can have a chat about how we could organize that. I think my team will be able to dedicate some development resources to it as well. So we could possibly talk about if we want to collaborate on that feature set. Okay,
that'd be great.
Yeah.
And then the second thing is, so I'm starting a podcast through Open Robotics, and basically the criteria is it has to be interesting to me. I did a robotics podcast for many years through RoboHub, which is another robotics news organization. But so I'll be doing one through Open Robotics. And if you got just putting it on the radar, if there's anything that would be good to get more visibility on, feel free to run it by me. We're launching the first episode probably in about 2 weeks. And then it'll be a bi-weekly podcast, long form, so like at least an hour or so for the interviews. But just wanted to bring it up. And I'll be asking if anything is particularly interesting to me during these meetings too, to see if anyone would like to do an interview.
Cool.
That's it for me.
Yeah, thanks for the updates. I assume we should do the next meeting as final bookkeeping, which would be on the 26th. So I'm just going to make the notes now, and we can plan to meet then. I'm going to be out on vacation for most of the time in between then, but I will be here to help guide conversation. So I probably won't make any progress on any of the stuff we've talked about between now and the next meeting. We can always cancel them if we don't have anything to talk about. But thanks everyone for coming today, and I'll see you the next time.
Great, thank you.
Thanks.
Bye-bye.